Number 42. 3 blocks are connected with each other by 2 light strings. The blocks have different masses, where mass 2 is greater than mass 3 is greater than mass 1. The heaviest of the 3 blocks is placed on a frictionless table. The 3 blocks are released from rest. What's the acceleration of block 2? All right, so a free body diagram. First off, we could say that there's that these masses will accelerate in this direction, right? So they're going sort of in a clockwise fashion. We can call this a tension force going this direction, and somehow we change colors. And we have another tension force going in this direction. So let's sum up the forces here. We have M1G down, and we have tension force 1 up. We have M3 down, tension force 2 up. All right, so for mass 1, we can sum up the forces as M1A. We have tension 1 minus M1G equals M1A. Tension 1 equals M1A plus M1G. For mass 2, we have the summation of forces equals M2A. In this case, we have T2 minus T1 equals M2A. For the third mass, we have the summation of forces equals negative M3A. Tension 2 minus M3G equals negative M3A, or tension 2 equals M3G minus M3A. Okay, what we can do now is we can use this equation, and we can place for tension 2 this, and for tension 1 this. So tension 2 here is equal to M3G minus M3A, and we need to subtract quantity M1A plus M1G, and that's all going to equal this M2A from up here. So we would have M3G minus M3A minus M1A minus M1G equals M2A. All right, so let's get all the acceleration terms on one side and everything else on the other. So we have M3G minus M1G equals M1A plus M2A plus M3A. We can factor out G on this side, and we're going to get G times quantity M3 minus M1. Factor out acceleration on this side. Now, if we divide both sides by M1 plus M2 plus M3, we're going to get acceleration equal to G times quantity M3 minus M1 all over M1 plus M2 plus M3. Answer C.